Okay, today we're going to be continuing what we did last time, looking at velocity and distance. And last time we did it just for regular functions. Today we're going to do it looking at trig functions. Okay, so a couple of things, just a quick review. When velocity is positive, it's a plus sign. You know it's going right or forward. Okay, when velocity is negative, it's going left or back. Okay, and the way we tell that is if it's below or above the x-axis. Okay, so if the graph's above the x-axis, it's positive and going forward. If the graph is negative or below the x-axis, we know it's going left or backwards. And along with that, if it's actually on the x-axis, we know that the object is stopped at that point. Okay, so we're doing this for trig today. So one thing to get started here, we want to hit zoom and then go down to number 7 here, which is trig, because it'll make it easier for us to tell on our trig graphs what's happening. When you see the graph of trig right here, each of these little tick marks, so this one, this one, this one, each of those counts for pi over 2. So this one is pi over 2, this one is pi, this is 3 pi over 2, and this is 2 pi. So our first function is sine of t cosine of t from 0 to 2 pi. So we're going to put in sine of t in the parenthesis, cosine of t in the parenthesis, and hit graph. And if you have zoom trig on, it will look like this. And we're only concerned with this graph between 0 and 2 pi. So I'm going to sketch that on my paper here. So we have pi over 2, pi, 3 pi over 2, and then that would be 2 pi. Okay, this graph at 0, 0 is crossing the axis. It looks like it crosses again at each of our marks, so it should be easy to work with. It goes above, down, and through, and kind of down. So the first question is, when is this particle moving to the right? And there's several times where it's above the axis. Between 0 and pi over 2, between pi and 3 pi over 2. So these two parts where it's above the axis. So we need to write that. So from 0 and pi over 2, and also from pi to 3 pi over 2 is above the axis. So from pi to 3 pi over 2. Those are 2 times it's moving right. Where is it moving left? Those are times when it's below the axis. These 2 times right here. So when is it moving left? From pi over 2 to pi. And then again, the second part was 3 pi over 2 to 2 pi. So 3 pi over 2 to 2 pi. Last question on this slide is, where is this particle stopped? That's any time where it's crossing the axis. So this, we don't even have to use our calculator on this one. We can kind of see it's at pi over 2, pi, 3 pi over 2. I'm not going to say 0 and I'm not going to say 2 pi because if you look, this is a non-inclusive on our graph. So the 2 times during our interval where it stopped, it's t equals pi over 2. I guess 3 points it stopped. Next one is pi, and then 3 pi over 2. But we're not going to count 0 or 2 because they're not part of the interval. So that's how we can tell it's moving right above the axis, left below the axis, and where it's stopped, where it's actually on the axis. Okay. Next things we want to talk about, displacement and total distance traveled. Okay, we talked about this the other day. Displacement is just the integral. And what that means is, where did it end up? Forward or backward from where it started. So when we do this, it's going to be everything, the area inside of here is positive, the area inside of here is negative, positive, negative, and we'll add those all up and see where they are. But the easiest way to do that for us is to do the integral from 0 to 2 pi of our function, sine t, cosine of t with respect to t. And that's going to keep the positive positive, negative negative, and it'll kind of tell us where we end up. So I can hit second calc, go down to option 7, and it'll say lower limit. Our lower limit is 0. What's your upper limit? I'm going to put 2 pi. Here's our integral being filled in. And here's our answer. It is 0. So its displacement on this was 0 meters. Okay, it ended up the same place it started. And you can kind of see that because it went to the right, then it went to the left, then it went to the right, then it went to the left, and ended up right where it started because those are all equal areas. Now, total distance traveled doesn't consider any negative, so everything's going to be positive. So one way we could do that is define each individual interval, make them all positive, add them together, but that's kind of labor intensive. So what we can do instead is the interval from 0 to 2 pi of our function, but we're going to take the absolute value of that, sine of t, cosine of t, with respect to dt. So we got to do absolute value. So the easiest way to do that is on our calculator. We hit math, and then go down to option 9, our interval. We're going from 0 to 2 pi. We come in here, we need to do absolute value. So you're going to hit math, go over to num. Number 1 is absolute value, the absolute value of, and then we're going to put in our sine of x or t, parenthesis, cosine of x or t. With respect to, and we're going to use an x in here since that's the letter we're using, and when we calculate that, it would make all those distances positive and add them together. Looks like 2. So how far did it travel? 2 meters. So if we go back and look at our graph and kind of really tell what's happening here, the object went positive 1/2 meter forward, 1/2 meter backward, 1/2 meter forward, 1/2 meter backward for a displacement of 0, but a whole distance of 2 meters traveled. So it's nothing really new from yesterday or a couple days ago. It's just doing the same thing with trig functions. So make sure you switch your calculator with zoom trig and realize that each one of those tick marks is pi over 2. Make sure you're in radians mode. One other thing, when you need to get your calculator back to normal for yourself, you're going to hit zoom, and then 6 is going to get you back to your regular 10 by 10 graph. So that's one last thing to note. Hope you all are doing well. I'll be on our live sessions if you need extra help. Have a good day.